Welcome to qnawire.
Here in this problem we are given with an insulated vessel and in which ice of mass 250 gram, so it will be equals to 0.250 kg, and the temperature of ice is, initial temperature of ice is 0 degrees Celsius, and it is added to 600 gram of water at 18 degrees Celsius. That means the mass of water is given as 600 gram, so it will be equals to 0.6 kg, and the initial temperature of water is given as 18 degrees Celsius. Now we have to find the final temperature of the system. So first of all, we'll calculate the heat required to melt the ice. So it will be equals to Q equals to M into latent heat of fusion. So mass is 0.250 kg and the latent heat of fusion is 3.33 times 10 to the power 5 joule per kg. So we're going to simplify and we'll get the result as 83,250 joule. So this is the value for Q. That is the amount of heat required to melt 250 gram of ice. Now we'll calculate the heat required to cool 18 gram of 600 gram of water to 0 degrees Celsius. So it will be equal to mc delta T. So mass is given as 0.6 kg and C is the specific heat of water, which is 4186 joule per kg degree Celsius, and the change in temperature is 18 degrees Celsius. So we will get 45,208.8 joule. Now this was the heat for water and this for ice. Now if we compare that, the heat for ice is greater than the heat for water, so we can conclude, since the heat required to melt 250 gram of ice exceeds the heat required to cool 600 gram of water from 18 degrees Celsius to 0 degrees Celsius, so the final temperature of the mixture, that is system water plus ice, will be 0 degrees Celsius. So this is the final temperature. So this was the answer for the A part of the question. Next we'll be solving the B part. So in the B part, we have to find that how much ice remains when the system reaches equilibrium. So for that, we'll be using the first law of thermodynamics, that is Q of cold will be equals to minus of Q of hot. That means the heat lost by the ice will be equals to heat gained by the water. So let us assume that M amount of ice is melted. So M times LF, that is the latent heat of fusion, will be equals to minus mass of water times the specific heat of water times delta T, that means change in temperature. So the final temperature is 0 degrees Celsius and the initial temperature, we know it is 18 degrees Celsius. So we can plug the value here. From here, M will be equals to minus MW, the mass of water is given as 0.6 kg times the specific heat of water is 4186 joule per kg degree Celsius times the change in temperature is minus 18 degrees Celsius divided by latent heat of fusion, that is 3.33 into 10 to the power 5 joule per kg. So it will be equals to, mass comes out to be as 136 gram, and so the final ice remaining, the mass of ice remaining will be equals to, the initial mass was 250 gram, so 250 gram minus 136 gram, and that will be equals to 114 gram. So finally we can conclude that the ice remaining, the mass of ice remaining is 114 gram. So this is the final answer.